Hello everyone, my name is Siddhant and today I'll be presenting on the topic of seven segment display. This is basically an innovation video that is performed by me in the lab. Let us begin with the presentation. So the first slide says what exactly is the seven segment display. So it is basically at its core, it is an electronic display device which is made up of seven LEDs labeling through G and matlab, that is or D dot arranged in a specific pattern that allows us to perform numbers and characters various by multiple permutations and combinations. There is also an optional 8 LED uh, as the decimal point, commonly referred as a DP. Each segment can be turned on and off independently, and through this, we can display like 0 to 9 and several alphabetical characters by using this. So the next is this. This is key. How many types of second segment displays are there? In general, we would find two main types of science element display. First is common cathode, and the second is common anode. In a common cathode display, all the cathode terminals are connected together to logic 0, basically ground. Individual segments are lit up by applying a logic 1 signal, and the reverse is true for the common anode type display. It's opposite. All the anodes which are tied together to logic 1 are VCC, basically. Segments are activated by pulling them to logic 0. In the common let's move on to the next slide. In the common cathode, we have seen that if we apply logic 0 to the to a specific unit, like to display the specific A, then it will glow up. And in the common anode, we have to provide the logic 1 to for the same in order to display. So this was the circuit diagram. We can see here all the common cathodes are connected together, and each cell is connected to its A, B, C, and respectively. Here, common anode. We can say it vice versa. So if we take a look on the common anode second segment display, then we have this. For example, if we want to display like the A, B, C, D, E, F, and we do not want to glow the G LED, then like the following display code will be this, because this is for the common anode type. So displaying 0 will glow the LED, and if we have the state as 1, then it won't glow it. So here DP and G is 1. So the G segment is not lit up, and also the dot 1 is also not lit up. So moving on to the next. So this is the truth table for common anode type. Like to display this segment to be on, we have to take them as 0, because 0 means for common anode type means that the specific segment is lit up. So like we can perform and we can make these types of arrangement according to these codes we have represented here. Like here only G is missing, then we can obtain 0. And if we are turning off A, D, E, F, and G, basically these are all ones, and these B and C are 0, then we will have the following code as 1. So these are the also results we will get, like 0 will be this, 1, 2, and 3, and so on. So yeah, we can make any kind of combination following these type of pattern. Now, in order to display good, it is the following code we are using. Like this is the code from the manual, and every remark and every mnemonics is labeled just right after the code. So like we can follow the procedure through this code in order to display good. Now, this is half of the part of code. Now, the another half is this. And in last, we have entered the details like of whatever the things we are going to display. So these are the details for the same. and here is the output result for the same. So let me play it once for you. So this is the experiment result. Like we are displaying good. Let me play it once again. Like GOOD. Like one thing that is to be noticed here is that the results that we are getting here is coming from like the leftmost end to the rightmost end. Okay. So the like order of operation is key. The text is moving in the rightward direction. So like like let me take it to the next slide. Like now for the uh, now for the innovation part, what I have done is like how about if we do the same, but if we do not want to display the text from like in the rightward direction, but to leftward direction. So the solution came to my mind is that if what if we physically flip the 7 segment display by 180 degrees, but of course flipping the displays like it will only show the mirrored positions. Now of what exactly we also need to do is that we also need to invert the hex code for the character, for example, to display the letter L. After flipping it, we don't use the hex code for L, we will use the hex code for 7, like which is basically the mirror image for L. So this way, like if we display the code like in the inverted manner, we will get it from we will get it into the leftward direction. So if like what I have done here is I have tried to display the thing IITR. Oh, sorry. I have tried to display follow IITR from right to left into the reverse manner from whatever I have done till now. Like we saw it that we were displaying good, but it was from left to right. So these are the following codes. I have obtained it from the previous table. Like let me show it to you. So this from this table, I have obtained all the things that are required. But see, from here we can see that we cannot display W. For W, what I've used is I've just simply displayed U. So that's why the code isn't mentioned here. है ना? So like if we just repeat the code I have shared in the previous slide and follow the characters from the memory 2100 like in the previous one. So we will basically get every character, but in the opposite manner. So for the next part, like let me play the video for you guys. So here is follow IITR, but it is coming in the leftward direction. So yeah, basically this was this was it. So yeah, so thank you.